Okay, so I did explain how to get the internal force on the whiteboard. And make sure you go through all the examples. Right. Okay. Now today we learn about converting what you learn in internal forces into diagram, because this one, the previous section is you can only find the focus load. You don't know what happened inside the bodies. So you want to do scanning by presenting all the internal forces, the bending forces, the shear forces by a diagram. So called shear moment diagram. So beam, what is beam? Beam are structure members designed to support loading, applied perpendicular to their axis. Right. So this is beam. So generally they are long and straight, have constant cross-section area, and they often classified as how they are support. Okay, so this one is a beam with two types of support. So this one you should able to convert into x1, no moment. This one also one. So remember to convert this distributed load into focus load when you do analysis. And this is P focus load and so on. Okay. So this beam will always given a total length L, and all the dimension to the forces will be given. Okay, so we're going to convert this diagram, all these forces, including all the external forces, into these two diagrams, V and M. Okay, V and M. So will be, I think this will be your first diagram. So when you solve this kind of question, remember to put the two diagrams in the same pages, same page. Usually I will just divide my page into half. Then you draw V and M, V and X. X is the length, right? This one from zero length to maximum length. This one, the second diagram is moment. X-axis is your length. Okay, you draw the same on the same page. Axis, do it parallel. Okay. Then the next one is you put in the parameter. Okay, the parameter that you see on the question. For example, you see the total length L. So the maximum line that you can go is your L. You just transfer the information, right? Because V and M is linked to each other. So you need to convert what happened in the V into M later. Okay. So you copy the total length, and then you have a A there. So you just put in the A. You just write A here. And then there's a B. So you just copy the B value. Okay. B. Of course, in the question, you will see numbers lah. We just use alphabet just to give you the ideas. Okay. So then the rest I'll teach you from the next slides. So you convert the V into M. Okay. Okay. Okay, now general idea of how to see whether you draw the correct or the wrong diagram. If you look at the diagram, you start with the L first. So L means shear loading. So shear loading V over here be maximum divided by this one will be pressing. So the load will be going this way. So from this point onwards, you are loading the shear force. So you go to the positive value. Then as you go to the right, the shear force will reduce. Then if you see the arrow point down means the line will go down already. Will go down. Then when you reach focus force, it will load the shear loading. This will be the magnitude of your force. This one will be force means it will go down. If you draw V, and suddenly your graph is go up, then wrong already. If you draw the V diagram, when you reach, like for example, focus load P point down, but suddenly your graph jump up, then wrong already. You must follow the direction. When you press down, the shear force will point down. And the magnitude of this one will same as this one. Okay. Then you go down. Then if nothing there, then you just go to the flat one. The flat. If nothing here, then you just follow the shear loading and then you go up. Okay. So this one, why go up? Because when you draw the external force, your force at this roller here will point up, right? So when the force point up, the line will push up. Same with here. There's a let's say this is point A. Point AY will be push up. So there's a line push up there. Okay, push up, then the arrow point down. So there's a reducing of forces. So the reducing of forces here to here represent this one. Okay. Then if nothing, then you'll see flat. If there's a nothing space there, then flat. Nothing, flat. Yeah. So this is how you check your answer whether you draw correct or not for the V diagram. Yeah. So you need to know how to solve the internal force first by using all the force equal 0, all the moment equal 0. You solve the external forces first. Then only you come to diagram. This usually is the first section of the question. This will be the second section. This one will be one question. Okay. So here will be 12 marks. This one will be more marks. This one will be 13 marks. Okay. Now, how to find moment? Moment is the same as all the moment equal to 0. Okay. So basically is area under this graph. Area under the V will represent the moment. Okay. So later I will teach you how to convert all these lines. Okay. The moment not necessarily positive. It can be negative. Okay. So this is called shear diagram. This is bending moment diagram. Shear diagram is V. This is bending moment M. These two diagrams is to analyze internal force. Is to analyze internal force. So this one, if you go into higher level, you might see this one already in the computer or on the simulation software. Right, but this will be the basic how the software get the result for you. Okay, so let's see straight away. I teach you how to, because we already assume you know how to do the internal force analysis already. So just convert the first section information into the bending or shear diagram. So draw the shear moment diagram for the shaft shown in the figure. Support at A is truss bearing, and the support at C is journal bearing. So one is truss bearing, one is journal bearing. So you convert the diagram into loading, because journal bearing and truss bearing, they're able to move in X direction. So no X, no support in X. Be able to rotate, so no moment. So in A you have AY, in C you have CY. Copy the external force. Okay. So one of the careless mistakes, usually you will forget to copy the question external force. Sometimes moment. Sometimes the question gives you moment. So remember to copy the moment. Okay. So this one you already know already. So how to solve? All the force equals 0, all the moment equals 0. Okay. So moment, it depends. If you want to solve C, you close C, you can solve for A. But moment at C equals 0, you can solve AY. Moment at A, you can solve CY, or all the moment equal, all the force in Y direction equals 0. You can find the AY plus AC equal to 5 kilonewton. Then use the moment to solve. Okay. Anyone don't know what I'm talking about? Can I? All right. So we use all this equation. You arrive at this or few equation. All right. So AYAC equal to 2.5 kilonewton. Right. So once we have the value, now we start to build the moment, shear moment diagram. So shear moment, you prepare the template. You draw V versus X on the top, N versus X in the bottom of the VX diagram. Okay, because why? You need to transfer the point. You need to trace the point. Okay, of course you can split like if you're able to imagine them, they are same, then okay. But it's a good practice if you can trace the line and put them together. Okay, so we want to start to do internal analysis. So we put an X on the AB, between AB. So as you can see in this diagram. Okay, so AC, you have AX 2.5 kilonewton and there's an X there. Just draw it. Then write X 0 to 0 to near to 2, not 2, near to 2. And the shear loading I already explained. Direction one is go up, one go down, right? And the moment is here, right? So why the moment is here? Because when you press this 5 kilonewton, the rod will smiling, will bend and smile. So how to do smiling? So this one, okay, so this one will do anti-clockwise. Huh? Okay, this M we just assume. You can assume any direction now if you want. Okay, so here, okay. So we just assume, if we don't know, we just assume, right? And we assume it act in a positive sense in the right-hand face of the segment according to the established sign convention. So there's a sign convention for that, right? So sign convention, this one will follow the process, and then this one we will, if you don't know, we just assume anti-clockwise. The moment will be anti-clockwise. If we don't know lah, we don't know. Okay, so here you solve for the component, all the force in Y equals 0, or the moment in Y 0. Why there is no X there? Why there is no contact force or normal force for this segment? Why? Because earlier we say got, right? Okay, here. Why when you cut the X, no X direction? Why? What do you think? Why we didn't draw the tends to connect forces? Why? What is this connection? Thrust bearing and journal bearing. What happened to the X component? There is no X force there. Okay. And even you try to solve, you're equal to 0. And what we are trying to solve, the question asks you to do shear and moment diagram. What is shear? What I mean by shear? Shear is when the force go parallel to the area. Okay. The diagram asks you to find V. So this force is V. So you don't need x direction force for Vx and Mx. You don't need that. Okay. So once we solve, our shear force will equal to 2.5 kilonewton. Moment equals 0. So moment at V point will equal 0. So your M will equal to 2.5 x kilonewton meter. I already skipped the working. If you don't know, you need to raise your hand, sir. I don't know how to get down. Right? You need to let me know if you don't know. Okay, so when you solve for for M, you put your hand here, V force gone, you only see M, anti-clockwise positive. So this one, clockwise, so negative. So M plus M, positive M, minus 2.5 x equals 0. You move your minus 2.5 x to the right hand side, you get this one. Okay, so you have equation here already. Now this one first. Okay, so you draw your shear diagram and bending moment diagram. So put in the unit, because what you see in the question is kilonewton, so you put kilonewton. This one is kilonewton meter. Put in the unit. Okay. So there will be 1 mark for the axis, 1 mark for the axis, 1 mark for the axis, 1 mark for the axis. The graph alone will cost you, if you give the correct axis and the dimension, will really score 4 marks for the diagram, including the unit. Including the unit. Okay. So you put in all the value, 2 meter, 4 meter, so on. So this is a total length. X is a total length. Okay. So you start by giving. So your V from here, from A to B is the constant value. Your calculation constant value, 2.5 kilonewton. So you put your graph, go and pick 2.5 here, and then draw a constant, right? Constant, because here the V is 2.5. So start from here already 2.5, and there's nothing there, nothing here, so flat. Okay, so this will be the area. This will be the area. So when you draw the diagram, for example, this one, when you draw the diagram, you just shaded the area. So I know whether you are talking about positive or negative value. Okay, remember to shade it. Okay, now how to find this one? How to find this one? You know the straight line equation. If you have a straight line, y and x, this straight line will give you y equal to mx plus c. So you have an equation m equal to 2.5 x. So this is m, this is x, your c is 0. So 2.5 x, how you find the point here? You have the length, right? 2, right? Substitute 2 here, what do you get? 5, right? You extend to the left, right, 5 there. And then remember to draw this line, and then shaded the area. Is actually translating from your equation here. Any question for the first part, A to B part? Yes. Ah. Yeah, there is a case later. I'll show you. There's a case when you have a distributed load, either push up or push down. Okay, now it's empty. On the surface is empty, nothing there, so it's flat. But when there is a external force or there is a external distributed load, then they will be. Okay. A to B, A to B. B, yes, internal force. AY, it will affect the V. It will affect the V. Yeah, but we doesn't care the external force anymore. So we only shear diagram and bending moment diagram is actually explaining what happened inside the diagram. Okay, so like for example, in this case, when you design the structure, you know that your structure need to hold 2.5 kilonewton for the section A to B. The material should strong enough to hold 2.5 kilonewton. This one also. The critical area between A and B, it should hold 5 kilonewton 5 kilonewton meter when it reach B section. It cannot break. So you need to design, make sure to use the material able to handle that. Okay, so it's fine. Yeah, so this one you need to write in your solution. You need to write how you get 5. So you write when x equal to m equal to 5 kilonewton meter. You need to write this one. Don't suddenly give me one number, I will circle. I cannot find your explanation, I will circle. Although the answer is correct, but I won't give you mark. Don't suddenly give numbers that you don't explain in your solution. Okay, we have done the first part. Now we go into second part. So this one is important. You write the equation also. Straight line you don't need, but any line or any curve, please write the equation on the graph. This one you write m equal to 2.5x from your equation. So this is 2.5x is increasing, your m positive. Okay. The second part. Okay, the second part is from 2 meter to 4 meter. Equate this symbol. Not touching 2, because 2 is a sensitive area, so we don't want to go into that. So just 2 meter, more than 2 meter until 4 meter. So it is 2 meter until 4 meter. But in this case, again, we are looking at here. Okay, look at here, this section. So here, from A to the section BC, X. B to C, this section is X minus 2, this section. So we already do this section, so we no need to focus on here. A to B we already done already. So we want to focus what happened here and to the 4 meter. Okay, so this is give you the general idea what actually happened to the diagram later. Okay, so careless mistake usually will be here. You are stuck here because you are so focused on the second section. Remember, reference point always same. From A, if you first part you do from A, then your X for the second part will from the A, right? Okay, so when you do your equilibrium equation, okay, equilibrium equation, you will get, you want to find the V here, the shear loading here. So again, how you draw the shear loading when you cut, you use the positive sense. Positive sense means you refer to the external force. On the left hand side, usually you will point down, and we use anti-clockwise positive. Okay. So all the force in y direction equals 0. So 2.5 kilonewton go up positive. 5 kilonewton push down, minus V equals 0. So this one you get your V equation. V equal to minus 2.5. Okay. Same with the M. So close your hand at the X direction. So V gone. So you have M, anti-clockwise positive. This one clockwise, negative 5 kilonewton multiplied by this distance. And A multiplied by this distance. Yeah. So you get this equation. Rearrange, you want to get moment equal to what? Rearrange, you'll get moment equal to 10 minus 2.5 kilonewton. V now is what? Minus 2.5. So V for the section after BC will be minus 2.5. Go to your graph, label minus 2.5. Okay, so you go minus 2.5. And then because here to here nothing, so flat. Yeah. Then you need to cross check. Every time there is a focus load, this is 5 kilonewton, this 5 magnitude here must able to see on the shear load, shear diagram. This 5 kilonewton, the magnitude must same as here. Positive 2.5 minus 2.5 is 5. 2.5, 2.5 plus is 5. Pressing down. Pressing down. Okay, then flat. Any question for the shear diagram? No, Yes. This one, right? You're asking, okay. So this one V, we always follow the positive sign, where if you really don't know, you just draw down for the left hand side, for the left component. You split into half, right, left, right. So you always go down. Then if you really don't know, then you draw anti-clockwise. The moment anti-clockwise. Okay. This one, I'm not following the common sense here. So on the whiteboard here, so we draw the anti-clockwise. Okay, so again, what you see here, m equal to 10 minus 2.5x. This is y equal to mx plus c. You're able to draw y equal to mx plus c. Now your y equal to minus 2.5x plus 10. So now you have 2, you have 4. I'll talk about moment. When you reach 4, it should be 0. You substitute 4 here. Minus 10 plus 10, it should be 0. When it's 2, you multiply 2 here, it should be 5. So like this. If you extend this one up, you'll reach 10. But we're not interested in the intersection there. We are more focused on what happened to 2 to 4. Is that? So how you get this number, just substitute inside there. Okay, how you know you did the wrong answer? Especially when you reach there. You won't get the, if you answer do not get 0 at the last corner, means your answer is wrong again. Again, it's depend on case lah, but most of the time you arrive at 0. Start from 0 and with 0. Okay. Any question on how to do the shear and bending diagram? Make sense, huh? Okay. So I just highlight the line. So when you draw, just highlight the line lah. Okay, for the shear, just highlight the line, shaded the area. Okay, so this is a complete answer lah. With shaded area blue, and of course in exam you don't have a color pen here. You just shade it with the line, and then you highlight your line with the board. Right? You can use pencil, but just draw a little bit more for the line. Okay. Remember to write the equation. Straight line, flat line like this, you don't need to write the answer because it's very straightforward. All right. Okay. Now another example, right? So same. Every time you see the question asks you to do shear moment diagram, prepare the template first. Draw VX, MX, copy all the dimension line, right? So here you have 0 to 9. And before you solve, you do the first part first. It means you solve all the external forces. All right. So here, external force here, you have a pin. So pin cannot move left, right. So you have, let's say I label this one as A. So you have AY, AX. This one also, you have AY. But you know that this one, there's no X component. There's no X component. So your AX equals 0. You still need to do lah. You still need to write AX equals 0. Because when you do all the force in X, all the force in X direction equals 0, you get AX equals 0. So you also explain later when you cut the diagram, your X direction is 0. No contact force in X direction. Okay. So I assume you already know how to do the external force. You draw the free body diagram. And free body diagram, again, remember this is the first part homework. First part homework. So you already know how to convert this triangular distributed load into focus load. How you do is that you see this one as a triangular. How you find area under the triangular? So base multiply height multiply by half. Okay. Then where is the location of triangular distributed load? Always 1/3 of from the base. Okay, so they always 1/3 from the base. This is the base. Okay, so you put in there, you get 27. Who don't know how to get 27? Who don't understand why 27 kilonewton is shown on the screen there? And you try that you get the 27 kilonewton by calculating the area for the triangular. Okay, so this is just a starting part. So when you solve for the V versus X, M versus X, you need to be careful. You need to carry the original distributed load. Don't ignore the 27 kilonewton, right? So when you cut the thing, the distributed load you need to carry the original one, not this one. Why you calculate 27 kilonewton here? Because you want to solve AY and BY. Yeah, this is the first part, solving the external force. Again, using the equation of equilibrium, or the force equals 0, or the moment equals 0. You will get AY and BY. Okay. Always good to write in the general equation first, then only you substitute the value. Because sometimes you will press the wrong calculator button, and then the rest of the question is wrong. Although the step is correct, but one little step, if you, let's say you press the calculator and maybe you see the wrong, sometimes you 8 and a 3 in your calculator, or 6 in your calculator, no low bet already. You sometimes you don't see the digit. Okay, so this one is just show you how to get this one. So when we work into the Vx diagram, we will do a little bit of sketches for the distributed load. We draw the triangular and then draw the length, Newton per meter. We want to find x. What actually, when you move to the right at the x, what happened to the w? So what do ratio w divided by x. So this is w divided by the x equal to 6 divided by 9. Okay, then you rearrange, you get the w ratio in the x term. The additional step you need to do. You need this time. In, huh? So okay, so this will be you try big triangular into a general triangular distributed load diagram. Okay, from 9 meter, you change to x. From 6 kilonewton per meter into 2 over 3x kilonewton per meter. So it doesn't care what is the x. So okay, so this is 9. So you just do into a general terms. Huh? Okay, so same diagram, and then you can find the focus load on the general triangular diagram. So how do you find the focus load? Find the area for this triangular. Base height half, base multiply height divided by half. So you'll get 1 over 3 lah. Sorry, 1 over 3 is the distance from the base, location of this arrow. Okay, so magnitude of this black color arrow is base is x multiplied by this one divided by half, you get this one. That makes sense, right? Okay. Okay, so you write in this at the side of your sketches, f resultant of this one will equal to 1 over 3 x squared. Okay, once you have that, we will solve the unknown. So this one I will do very fast. Of course, remember to change this one, the moment of O, according to the point that you refer. So if you do calculation with O, I will go and find what is O. So if there's no O, I'll highlight this one. Where is O? Consider, if you write this one, I will consider wrong equation. Okay, because no O inside there. So you put in all the equation. In this case, all the y equals 0. So you get one equation. And moment at B, you get A. After you get A, substitute back here, you get your By. AY equal to 9, BY equal to minus 18. Okay, so this part already, I already explained a lot already. Okay. So again, I just highlight lah, where y-ax equal to 0. Right. Now we draw the diagram. So we start from the left to the right. Still the same. You copy the left part, A, AY. If you scared that you got it wrong, you just find. Then later you substitute. So AY, then the x direction, positive to the right. And on the top, you have a triangular distributed load there. So just copy the sketches for the distributed load in triangular shape on the top of to get this 1 over 3 x squared. And also we explain how you get 2 over 3x kn squared. Okay. And again, you draw the x and the location of the focus load here. Use the positive sense where V on the left hand, on the left component will go down, and you use anti-clockwise moment. Then can you solve for the V by using the moment equals 0? Okay. So you have these two equations. Remember, this moment for the V diagram, remember to write MV because you are looking at the V location. If you write O, I will circle. Okay. So from here, you arrive at two equations. Copy the equation, put into the diagram. Okay, I'll just draw, prepare the template. Remember the unit, the unit is important. Okay, in this case, we don't put the location accordingly. It depends until what is the point we want. So in this case, we just do straight 0 to 9, or maybe 0 to 6, or depends. So we have the complete the template already. So Fy equal to positive 9. This V equal to something X. So you should recall what is quadratic equation. Smiling face, y equal to ax squared plus bx plus c, a positive. If we set face, a less than 0. Okay, this is what your a negative. A negative set face. So set face is what? Like that, right? Okay. This one is intersect where? Intersect at 9. Okay, your C is your intersection point. M, you do the same. Moment at V point. Close here, but you still see one moment here. Anti-clockwise positive. 1/3 x squared is clockwise. Sorry, is the anti-clockwise positive. 9 kilonewton is clockwise, so negative. So positive M, positive 1/3 x squared, negative 9k, 9x. Remember, multiply the distance. So here, so you reach at one equation. Here you arrive at cube equation. Almost like parabolic. This is just a conversion of lines equation. To meter. Because at the same row triangular, so it doesn't care. We just from 0 to 9. Okay. Because here there's no external force. There is no external focus load. This one only distributed load. Okay. So what you do, I will just go at point at 0, shear can be found when x 0. All right. So the point of shear can found when v equals, so when v 0 means on the graph here, you want to find where is 0. Right? So when this one 0, you find your x squared, so it's positive negative. If you get the answer for 5.2, so you just go and label 5.2 there, diagram. Okay, so this is a set face. So set face, it is from, it will intersect 0 here. So you just label 5.2. Okay, so On the graph, you don't need to draw this line. You just write 5.2 here. This just for tutorial question. I put it like this. Okay. Then what about the, okay, so of course 9 lah. Why 9? When x 0, you get 9. When x equal to 9, when x equal to 9, what you get? When x equal to 9, you press calculator lah. You get a negative value. Okay. So 81 divided by 3. What you get? Okay, negative 18. So here lah, you write negative 18 here lah. You draw and then you write 18 here. I didn't put because I need to some space here to explain to you. Okay. But in exam, if you put something like this, you write minus 18 at the point, you'll be correct. As long as you label clearly what is the point. Okay, so from M2, you want to find the value of M at this 0 shear here. You just substitute this one here. Press calculator. You get one M value. M value will be 6 or 3 significant. Okay, so go to the diagram. You write lah 31.2. And this one is parabolic. Parabolic is look something like this. Okay, so you put x0, and moment 0. At x equal to 9, if you put in 9 here, it will become 0. Yeah. So you have seen focus load, you have seen distributed load. Yes. Not necessary, not necessary. But because this is in this case, it is a parabolic shape. Parabolic shape. You can say as a maximum point, but because this is only have a distributed load. What happens if we have distributed load combined with the if we have a case something like this? Plus one more external force, then you will not become, it will not be a maximum point. If you stand alone, yes. If not, then you need to consider the external. Yeah. Okay, so these are the homework. You can see. Okay, so these are the things that when you combine two examples just now, focus load and distributed load. So here, and the differences between the example just now is the arrowhead. Just now, all the force is pointing down. Now, this example is all the force pushing up. It's like you're building a bridge and the wind is blowing from below the seabed. Okay. So again, your W is positive, go up. Your X is going to the right. You see what happened to the V and M diagram. Okay. So this one is just to explain what happened if you take a very close section on this one. So the forces at this small section is W multiplied by X multiplied by this small X here. Okay. W in the X function multiplied by delta X. It means you take this W multiplied by delta X. You get the focus load because you transfer the distributed load section into focus load every time. Then left, right, you see how what is the common sense when you draw the shear diagram. On the left will be go up, on the right will be go down. And on the right hand side always go down, and then anti-clockwise. On the left, if you cut left will go up, and then clockwise. Understand? This is we call common sense, common positive sense. Understand? Okay, so if you cut here, so if you cut here, this is on the right hand side, so you will go down and anti-clockwise. This one on the left, exposed, so go up and clockwise. Same as this. This is called positive sense. Yeah. So here, if you move towards the right, you have a delta V and delta M. Okay, the rest just further explanation. Okay, so what are the application of this one, like concrete beam on the highway, the cable support? Okay, blah blah blah. This one. Okay, this one will really show you how to calculate the K just now, fraction distance, by using ratio just now. So this one is just an elaboration on the how to get the external load and all these things. Yeah? Okay, so this one is just further explain. The slope of the shear diagram is the distributed load intensity. So slope of this one is the intensity of distributed load, if you have a distributed load. So if you change of shear will be the distributed load area under the ground. Okay, but this one, as you do exercise, you know lah. Right? Important you understand what we cover earlier. Okay, the rest you read from the slides. Slope of the moment diagram is the shear. What does it mean? If you reverse the example just now, the M slope, just now the M slope, or the dx dy here, dy dx here, the slope of each point will equal to the value in the shear, this one. Okay. So this one you go home and just look at it. So notice that maximum bending moment will happen at the point where slope dm dx equals 0, where the shear equal to 0. So just now, the example just now, you have a shear loading at 0 here. So you get maximum point here. Okay. So when your V0, your dy dx for the dm dx equals 0, the maximum point. When you do your graph differentiation, the graph maximum point, dy dx 0, you apply in this moment diagram. So the rest you read. Usually, most of the time, you rarely use the box on the right here. Important is this one. How you find, when you look at the graph, when V equals 0, they always maximum point in the shear diagram. Okay, so this equation do not apply force or couple moment act, since these two special cases create discontinuity of the shear moment diagram. This one, it means like the one I draw on the whiteboard. If the distributed load suddenly got one external force in the middle, then it disturbs this statement. You cannot apply this statement. This is only pure distributed load. Yeah. one is just further explanation, nothing. So this is just what I mentioned in the beginning. If the shear is positive, means go up. If the force, shear diagram will jump upward when the force act upwards. Just now the diagram go down because the force, concentration force pointing down. And even on the reaction force there, reaction force just now, the V is positive because your AY go positive, pushed up. So in this case, you know that the diagram will push up. This one also. So the change in moment is positive, or the moment diagram will jump upward if the moment is clockwise. Because we assume clockwise jump downward when it's anti-clockwise. So this one, you'll see a positive when MO is positive. So that's why the moment diagram just now on a positive side. We go a bit more. Okay, so in this case, you solve by using the first part, mean all the force equals 0, the moment equals 0, find external force first. Okay, so this one is mounted, so there is a moment here. This one cannot twist or cannot turn. So there you have a AX, let's say B. You have BX, BY, and moment at B. You just assume this one, if you look at the diagram, it go like this. So they will be clockwise. You want to balance the force. So your moment actually is clockwise. But anyway, you can assume anti-clockwise. You'll get negative number. Okay, so and then convert the distributed load into focus load. The purpose is to find the external load or the connection or the reaction. Yeah. So here you need to change this one 1.5 multiply 2, you get 3 kilonewton at the middle of this load there. Okay, convert into free body diagram, like what I show on the graph here. Okay, so again, in this kind of diagram, Bx will be 0 because all the force in X equals 0. And remember there is a moment there. So in this case, I'll just put anti-clockwise as positive. There's an M there. So I'm going to skip the solution for the external force. You should already know how to find already. Means you use the equation of equilibrium. Okay, you do your homework, you find By equal to something, M equal to negative something. So when you get negative, remember, go back to your free body diagram and change it to positive before you proceed into V versus X, M versus F diagram. So it's important you keep your free body diagram in positive sense. Okay, so in this case, when you get negative, please change it so that you don't confuse whether it's positive or negative. Yes. Yes, yes. Draw a new one. Draw a new one. So let's say you find and then get negative, then you draw a new for free body diagram. Then you write your Bx what value and B what value. You can just straight away write in the new free body diagram, write equal MB equal 11 kilonewton clockwise. Okay, then only you solve. Then only you solve. So here I put a note there. Okay, it's important you show the correct free body diagram. Sorry, a free body diagram, so it should be FBD. Okay, so once you have the sense there, but again, you see what happened if I continue with my negative there. Right. So you draw V versus M, and then copy all the distance. Then you start to start to cut the part, start to cut from here. Okay, start to cut from here. So A, you draw A and then X, then draw the V and anti-clockwise moment. Okay, 0 to 2 point. So you start to see this diagram. So why my V point up? Because I know that I need to balance the left-hand side. Okay, so you say, Alexander, can I put my V point down or not? Can. You will still get V negative value later. Because all the force equal 0. All the force in Y equals 0, you'll get your V negative if you arrow point down. Huh? Of course, this will be the positive sense of shear. If you cut normal one, you'll go point down. On the left, on the right will point up. Okay. So it depends on the area of exposure. So this one is exposed here. So of course, this arrow should be point down. But you know that if you point out, you'll still arrive at negative value. So you still need to withdraw the. Okay. These are the positive sense. This is just a early guess or early expectation or hypothesis. But when you analyze, you get negative, you need to flip the diagram. You need to redraw the diagram. Okay. Put every value in the diagram, positive value. Huh? Okay. So you do all the force equals 0. V is 2 kilonewton. So from here to empty, so you put that your V is so M is 2. So here, because of this arrow, 2 kilonewton push down. So you start from 2. This arrow push down. You start from 2, not positive. Okay. So if your arrow point up, then you will push up positive. Like example number, I don't know, previous one. Okay. So I just put a note there. Why negative and not positive? Because this arrow 2 kilonewton point down. Although your value is 2, but this one point down. Just be careful on that. Okay. Then your M is 2 kilonewton X. So you know that this is linear line. So linear line, V negative constant will give you M slope negative constant. You follow the slope. If this one negative, your M will be negative, although your calculation is positive. So your slope will become negative 2x. Huh? So what is the difference between example 8 and the previous one? Previous one, you don't have a focus load point down at point A. Previous one, you have a contact at A. That give you AY go up. But this one, you have the external force 2 kilonewton push down. So you get from 0 until negative moment. Yeah, just take this note here. Okay, so what happened when you reach the distributed load there? Okay, I draw this one a bit fast. So you continue to draw the diagram from A, from A to, and then the X you don't know. So you draw the X here, and there is again V in normal positive sense, the V should be point down, but you know that to balance the 2 kilonewton, it should be point up. Just to make sure my diagram is positive sign, in the positive, give me positive value. Okay, so you put in all the force equals 0, all the moment equals 0. So point down -2, and this one you convert. This one you need to convert again, carry the distributed load 150 kilonewton per meter, multiply X, you get the focus load here plus V. So your V will be 1.5x plus 2. You get moment. Moment, remember to change this one into concentration load, 1.5x, and then the distance is half x. Yeah. So here, V moment created by this one is 2 plus x. 2 plus x multiply 2, you get clockwise moment. Okay, so this one I just draw. So you put in 4, not 4. In this case, here to here is 2 meter. So you multiply 2 here, you get 5. But because it's the force is pushing down, so we go to negative. Huh? Okay. So some of you can try to put V point down. Then the equation will tell you whether positive or negative. I just follow the equation. Moment also same. You arrive at one quadratic equation. Quadratic, this one is sounds positive, but again is negative constant. So you give you negative constant here. So negative is a set phrase. So there is a set phrase. Okay. Then substitute value. This one is 2, not 4. Because from here to 2, here to 4 is distance 2. So it is 2. Don't substitute 4 there. Because you're looking at that particular section. Yes. Yeah. 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 Okay. So you see this one. This one, you close your moment. The moment at V. How you calculate moment here? 2 plus x, right? So you look back at the previous example. Yeah. Yeah. Because here you got one focus load here. Okay. The distance the differences is because you have a focus load there. So you take x to the v, and then you are given the distance of 2 here at the example 8. Okay, there's no forces here. Okay, So that's why we don't use the, sorry, different. So that's why we don't use the, there's no focus load in. Okay. So if you understand, go home, look at example 9. Huh? This one is another part, but the concept still same. You need to be careful on the positive and negative side lah. Okay. Try to, this is just to, yeah, okay. So again, if you see the arrow point down already, push down, means you are starting from the negative side. I mean, your graph is always at the downside. If your external load, you see all the load is pushed down, then it will be go down like that. Go example 9, your homework. Example 9, your homework, 10, your homework. So, oops. Okay, with this, we conclude chapter 7, yeah.